Hello. In this video, let us find the radius of curvature for r power n is equal to a power n cos theta. And we have to prove that this radius of curvature varies inversely as r power n minus 1. For this, we have to find this r1 and r2 and substitute in the formula. What is the formula for radius of curvature in polar form? This is in terms of r and theta. So we have to use polar form formula, and this is the formula r square plus r1 square power 3 by 2 divided by r square plus 2r1 square minus r into r2. All you have to do is find r1 and r2 and substitute in this equation. Since you have this r power n, a power n cos n theta, always remember take log on both sides, like how we found the angle between the two polar curves and all those things. So same procedure, take log on both sides. Before differentiating any polar, always take log. Sometimes without taking log also you can solve, and it is log m power n formula is what? N log m. So r power n, log of r power n is n log r by using this formula. Same way, log a into b is log a plus log b. So here log of first term into second term. So what we will do? Log of first term plus log of second term, and same formula we are using. If you want, we can write log of r power n, and in next step we can rewrite it. So log of r power n, I can write it as n log r, and then this is n log a plus log of cos n theta. Now we have just taken log, but what do we want r1? R1 is nothing but what? dr by d theta. What is r2? D square r by d theta square. So if I want dr by d theta, what I have to do? This line I have to differentiate with respect to theta. So differentiate with respect to theta. If I differentiate with respect to theta, n into log r differentiation is nothing but 1 by r, and then r with respect to theta, one more dr by d theta. R with respect to r means this term will not come. Since it is with respect to theta, dr by d theta is coming. And this first term is just a constant, which means it's a number. If I differentiate a number, I'll get 0. Log of something is 1 by something into differentiation of that something. And again, I remind you that differentiation with respect to theta, so I have written theta here. And simplify this, n by r dr by d theta is equal to 1 by cos n theta. And we know that cos n theta differentiation is minus sine n theta into n. That n, I'll write it here. Always don't write here into n, otherwise it look like an angle. You have to put a bracket. Always write the constant in the beginning. And now if we simplify, sine by cos is tan, 1 by r dr by d theta, because this n, if it goes to the denominator, this n and this n will get cancelled, and we get minus tan n theta. Or I can say, what do we want? dr by d theta. dr by d theta is equal to, that is r1 minus r tan n theta. This or r1, both are same. So one term we got it for substituting in the formula. We want r1 as well as r2, right? So differentiate r1 again with respect to theta to get r2. So if I differentiate dr by d theta, what I will get? D square r by d theta square. This side. dr by d theta is d square r by d theta square. Now you have a u into v formula. uv formula, always what we will do? Keep u as it is. Keep minus r as it is. And tan n theta differentiation is secant square n theta into n. What I told you, if you are going to write, put this into bracket, then you can take it to the other side. And second term, plus, keep tan n theta as it is and differentiate minus r. If I differentiate minus r, I will get minus r1. Or if you want, you can take minus outside and completely solve it. This is same as minus nr secant square n theta minus r1 tan n theta. We are done with r1 and r2. Now you have to just substitute these things in the formula. Already I've written the formula in the beginning, so directly I'll substitute. Rho is equal to, what is there in the numerator? R square plus R1 square. What is your R1? Minus R tan n theta. R square plus R1 square. The whole power 3 by 2. Directly I'm substituting instead of writing the formula. Divided by. In the denominator we have R square plus 2 into R1 square. So again minus R tan n theta t whole square. R square plus 2 into R1 square minus R into R2. R2 is here. And R2 is minus nr secant square n theta minus R1 tan n theta. We are done with substitution. We have to just simplify the terms. In the numerator, if you see, rho is equal to, if I take r square common, 1 plus this term minus will go because of the square, tan square n theta. Okay. But for everything, whole power 3 by 2 is there. Be careful with this. So I have taken inside this only, I have taken common, then we can take it outside. So r square into 1 plus this divided by denominator. R square plus 2r square tan square n theta, because the minus will become plus. And this minus and minus will become plus. Plus n r square secant square theta plus, and then next term minus and minus, r into r1 tan n theta. And if you notice, again one more r1 is there. We have to substitute back. Numerator I can write it as r square power 3 by 2. I can split this as r square power 3 by 2 into the second term. 1 plus, if I take r square, I will not get again r square here. Correct? This r square and this r square I have taken out, means this I have taken outside. So 1 plus tan square theta only. So it is secant square n theta, the whole power 3 by 2. Because if I expand this term, this r square has come out. So I'm not supposed to write it again inside. And this is the numerator, and coming to the denominator, again we have to rewrite everything. R square plus 2r square tan square n theta plus n r square secant square n theta. I missed the n here. Secant square n theta plus r into, instead of r1, again I'm substituting this. What is r1? Minus r tan n theta. Outside one more tan n theta is there. Tan n theta. This r1 I have just substituted. And if you see again, numerator r square power 3 by 2 means only r cube will be there. And okay, r cube will be there. And secant cube n theta will be there, divided by, here 2r square n theta, here minus r square n theta. I can write this, I can take r square also common, 1 plus this 2 minus 1 is 1. So only one term we will get. and one r square we have taken outside. I can rewrite this again. I have rewritten this. This r square I'm writing as it is. This 2r square tan square n theta minus r square tan square n theta, because this tan into tan. These two terms will become one term r square into tan square n theta. This I have written as it is. Numerator is the same. Denominator, we have taken r square common from all these terms and we have written 1 plus tan square n theta plus n secant square n theta. So what is tan square theta? It is nothing but 1 plus tan square theta is secant square theta, correct? So secant square n theta plus n into secant square n theta. Now if you see in both the terms which is common, secant square n theta, I'll rewrite this as just a simplification after this. Rho is equal to r cube secant cube n theta divided by r square secant square n theta. I'll take common 1 plus n. Of course, you can cancel this r square and this secant square and this. And finally, we will get the answer as r into secant n theta divided by 1 plus n. But what they told you, show that the radius of curvature varies inversely as r power n minus 1. This is what they asked us to prove. So how do I prove? Because there is only one r here. For this, you have to see the question. What is your question? Your question is r power n is equal to a power n into cos n theta. But we have this term secant n theta. What is secant n theta? 1 by cos. So I can write this as a power n by r power n is equal to 1 by cos n theta. I'm bringing this r to to this side and I'm taking cos to this side. Or you can say divide both side by r power n. So a power n by r power n. This side r power n by r power n will get cancelled. Take cos n theta to this side. A power n by r power n is equal to 1 by cos n theta is secant n theta. You can substitute in the place of secant n theta here. Therefore, your radius of curvature will become r into, in the place of secant n theta, I am substituting a power n by r power n divided by 1 plus n. That is equal to a power n into r power 1. And the second term, if I take it to the numerator, it will become, wait, let me rewrite this again down. So what I will do, I'll take this r down. So a power n by r power n into r power minus 1 into 1 plus n. That is nothing but a power n by 1 plus n into, I can write the power together, r power n minus 1. So now radius of curvature varies inversely. So directly means rho is equal to some constant into r power n minus 1 if it is direct. But here they didn't give you direct. What they gave you? Inverse. Inverse means 1 by. So rho is equal to some constant into 1 by r power n minus 1. What is that constant? A power n by 1 plus n. Hence we can say rho is inversely proportional to r power n minus 1. Most of the problems they'll ask you to prove that, then it's easy for us just to eliminate the constants at the end after this step. Okay, thank you.